We'll do that. Thank you for joining us today for Welcome Fridays with a Forester. And this is April 1st, 2022. Healthy Woodlands and Climate Adaptation by Eli Sagor. Also with me is Matt Russell, part of our forestry team. My name's Gary Wyatt, also Extension Forestry team, working on these Zooms for our clientele in Minnesota. And actually, we've reached outside the state of Minnesota as well. So today's topic and speaker is Eli Sagor. He's our extension specialist, also stationed in Cloquet Forestry Center and St. Paul campus in our forestry department. And he's going to be talking about healthy woodlands and climate adaptation. So in our Zoom today, we'll have the chat open for questions. So if you could put that any of your questions in the chat, we're going to close the Zoom down roughly around 10 a.m. or before. Could be going after if we have more questions. And then all of our Zoom presentations are recorded, and we're going to have them posted at the link below there is z.umn.edu and then /Fridays. Eli, I'm going to stop sharing and I'll let you share your screen and we'll get off.
Great. All right, everything look okay?
Yes, looks good, Eli.
All right.
Thank you.
Hey, good morning, everybody. It's good to be here. I've watched a couple of these Fridays with a Forester sessions, and this is my first time presenting at one of these, and I'm excited to be here. I appreciate Gary and Matt, the work that they've put in to organize these sessions, and I'm glad to be part of it. There are no April Fool's jokes in my presentation. I just want to say that off the bat. I did put something interesting in the chat from the Voyager Wolf Project. I hope most of you have seen that. It's pretty amazing. That might get your April Fool's juices flowing this morning. But happy April Fools to all who observe the holiday or the occasion. I want to say too, feel free to turn your videos on. It's entirely up to you. You don't need to, but it's sort of nice to see people out there. As well. So if you're inclined to do that, feel free. And if you prefer not to, that's okay. I'm going to be talking about healthy woods and climate adaptation. And before I begin, I want to share this picture. I just love this. I took this picture at Dave Jacobson's place in the middle of the state. He has done a really beautiful job supported by DNR on a bur oak savanna restoration. And what I like about this picture is that it helps us, it reminds us that when we're managing forests, we're really thinking ahead to the long term. This stand is only about 14 years old. You can see obviously in the inset a picture that was taken the day they planted all these bur oaks. 14 years later, they've got this beautiful tall grass prairie. And I took this at least 10 years ago, I think closer to 20. And I haven't been back there to look at it since. But forestry is a long-term thing. You know, we put roots in the ground, we put trees in the ground, and we have the privilege and the good fortune, we hope, of watching them grow and develop into whole new ecosystems as time goes by. And that idea, I think, is really salient as we talk about climate adaptation and, you know, take a long-term perspective on our woods. So before I go any further, if you're looking at the chat, you'll see Matt put this link in there. You're going to see several links throughout the slides. You can write those down or whatever. Matt might post in additional kind of individual links. But the link that you see on the screen here will take you to my slides, a live version that has all of the links active. So if you see something, you know, on slide 21 and you want to capture it, you don't have to scramble to write it down before I move to the next slide. You can just get this one. This link does appear on my last slide as well. So you'll be able to write this down later too. So let's start a little bit with a little bit on the climate. There is a large network, as I'm sure you all know, of weather observers around the state that are doing measurements daily or on frequent intervals of lots of things: rainfall, snow, fall, temperature, and so on. And if we, excuse me, if we look at the records that they have collected over the last 25 years, give or take a little bit, excuse me, 125 years, you can see that there are some real changes in what they have observed at their weather stations. The overall average temperature has, across the entire year, has increased at a rate of about 0.2 degrees Fahrenheit per decade since 1895. But the change, even though the line looks less steep, the change is about double that in the degree of warming that we've observed in the winter. So if we look just at winter temperature change in Minnesota, winter, in this case, the month of January, it's gone up about 0.4 degrees per decade. Winter really matters because when we're talking about trees, in many cases, not only tree species ranges, but also the ranges of insects that might eat our trees and damage them are limited by cold winter temperatures. It's not true of all of them, but it's true of many of them. So, you might hear about emerald ash borer when it gets to 30 or 35 degrees below zero, 95% of the emerald ash borer larvae die. Well, if it gets that cold less frequently, emerald ash borer might do better and our ash trees might do worse. I'll be talking about a couple of other examples of that sort of thing. So I'm not a climatologist, and I'm not going to get into a lot of detail on this, but I wanted to share some very basic data based on observations taken across the state. So I just said that climate regulates the ranges or limits the ranges of a lot of native Minnesota species. And I want to share a resource here that might be of interest to you. I encourage you to check it out. Again, you can write down the link that you see at the bottom of the page here, but you can also just download or look at the entire slide deck that I'm sharing here. So you don't have to scramble to write it down, but you can. The Northern Research Station at the Forest Service has developed these two atlases, one focused on trees, one focused on birds, showing how a changing climate is expected to change the ranges of various species. In other words, the places where those species can thrive. This is an old screenshot that I took in a previous version of the tree atlas. And I don't have the legend up here, but you get the idea. On the left side is FIA current. That means forest inventory and analysis. That's what shows us is currently on the landscape for this species, which I think is aspen. It's funny, it's covering up my my title on my slide. But the right side shows the prediction 100 years into the future. And again, you don't need the full legend to see that aspen is expected to be less abundant across Minnesota 100 years in the future. Again, I'm not going to get too deep into the weeds on this, but you can run whatever species you'd like through these atlas tools. And in general, what you'll see is that tree species ranges are being contracted in Minnesota and moving to the north and to the east. In other words, species that used to be abundant across a lot of the state, like what we see here, in the future are expected to be limited more to what we think of kind of the north woods, northeastern Minnesota. Another source of information about that, another way to think about that is in these figures. This is from a publication based on work done by Sue Galadowicz, Lee Freilich, and Laura Phillips-Mao back a little more than a decade ago. They looked at Minnesota's native plant communities and said, okay, if we look at, we know the current composition of those communities. What if we look at that time 60 years into the future? It's not 60 years anymore, but if we look ahead to 2069, what places on the earth at the time of the study look like what these areas are going to look like in 2069? So it's a little bit hard to wrap your head around. But if we're looking at, let's say, if we look at the middle of the screen here, Minnesota, the Mississippi Blufflands down in what we think of as the driftless area in southeast Minnesota in 2009, they're just like what they are. Well, in 2069, they're expected to be more like what we see in southern Iowa and northern Illinois. You can do something similar for different parts of the state. If we look here, kind of north central Minnesota up in the upper right corner, well, in 2069, the climate of that area is likely to be what we observe currently in northwestern Iowa. Very different. And, you know, it's hard to predict. No prediction, no model is perfect. But the general indication, again, is that things are moving to the north and to the east across most of this range. Again, you can dig deeper into the full text. There's a full text link at the bottom of this slide if you view the slideshow later on. Minnesota DNR has some really good resources about this. So if you're thinking about, oh my goodness, if the species I've got now are not going to be doing so well in 60 or 100 years, what should I put out there? There are good resources here. This is one good indication of that. The Climate Change Tree Atlas is another good indication. You can look at what tree species are expected to thrive in the future and think about what you want to do about that. I said that I'd give a couple of examples, and it may be just one, focused on, you know, how climate change affects not only trees, but the insects that affect those trees. Tamarack is one of our most widespread species. It's very abundant across northern Minnesota, mainly limited to bogs and wet environments, but not exclusively. It can do well on uplands too. Tamarack has a native beetle that affects it called eastern larch beetle. Larch is another word for tamarack. And eastern larch beetle always used to have one generation per winter. And now because of, per summer, per year. And now because of the longer growing season, it's got two. And in many years, that is leading to, you know, not just a doubling, but to exponential growth in the abundance of the eastern larch beetle. And at, you know, normal population levels, tamarack can fight off eastern larch beetle quite effectively. Unless tamarack is stressed by something like a drought or some other issue, it's just fine in the presence of eastern larch beetle. But with doubling of the exponential rate of growth, tamarack is being overwhelmed. And so we're seeing very widespread mortality in tamarack across northern Minnesota. Again, you can read more about this in the link in the lower left corner if you download the slide or look at the slides. But we are seeing some changes like this. Tamarack's an especially kind of bad example of it. But it's this kind of thing is the way that we kind of expect to see some of these things going. So you all, I assume, are woodland owners. You have an opportunity on your land and maybe beyond to do something about this, at least to help do what you can to keep your woods healthy and resilient. And I'm going to talk for most of the time about that. I'm going to talk about a few key ideas, the diversity in general. We're going to talk a little bit about native plant communities, but I'm not going to get too deep into that. It gets pretty technical. We're going to talk about general strategies. So what can you do beyond just maintaining diversity? So we'll talk about resistance, resilience, and response strategies, just to help you kind of categorize different kinds of approaches. And then I'll talk just a little bit about practical considerations. So the idea behind diversity, and I guess before I go any further, there will be plenty of time for Q&A at the end. I would encourage you to type your questions into the chat anytime, especially if anything I say is unclear and you want me to repeat it or state it in a different way. I'll do most of the questions at the end, but if I confuse you with something or you don't understand, I'm happy to pause and address that now. So I said before, I showed you a few models and I showed you what we've seen with climate data, but we know that no prediction is ever perfect. And we don't really know, it looks now like Minnesota is going to get warmer and wetter. But for a long time, we were unsure if it would get warmer and wetter or warmer and drier, even if the recent observations of wetter conditions continue. It seems like the pattern of precipitation is changing, where instead of having rain, light rain spread over several days, where a larger share of our rainfall is falling in the form of heavy drenching downpours. And that has implications for how much of that water becomes available to plants and how much of it just runs off and fills our rivers. The point is that we just don't know. We've never known what nature was going to do. There have always been storms. There have always been floods. We've never known what things are going to do. But it seems like the chance of larger scale changes is high. So what do you do under uncertain conditions? You hedge your bets. And that's what this diversity idea is about. I'm going to stop talking for a minute and give you a moment to read this. So in an ecological sense, I mean, you all understand the word diversity. In an ecological sense, what we're really talking about is this idea of functional diversity. So if you have a lot of different tree species, but they all ecologically play the same role, in other words, they all have, let's say, shallow roots, and they all disperse seeds in the same way, and they all have the same, insect pests and so on, then they're all going to respond in similar ways. But if you have diverse species that have, like this says, roots that go to different depths, some grow fast, some grow slow, they store different amounts of carbon and nutrients, and in a whole wide variety of ways, they complement each other rather than competing for the same resources, then you're likely to see different outcomes when there's, say, a flood or an insect outbreak. Eastern larch beetle doesn't really attack or do any damage to species other than tamarack. So if you have tamarack in a mixture with other species, you might lose your tamarack, but you're less likely to lose kind of the whole forest. Again, that's just one example. But this idea of diverse functional responses and thinking about what you can do in your woods to diversify the ways that different species are likely to respond to various kinds of disturbances, this seems like a pretty good idea when we're expecting bigger changes. So how do we think about response diversity? Well, you can think, I've listed a few categories. You can think about ages. I didn't say that earlier, but tree age affects not just the size of the tree, but it's how much wind it can withstand. Younger, smaller trees will bend over in a storm, where bigger, older trees might break off and die. Younger trees respond in a variety of different ways from older trees. Different species, obviously, that's a form of diversity. Different genetics and different seed sources. So one of the things that we see happening, not on a huge scale yet, but at a growing scale, is that public land managers and others are in some cases looking at diversifying the seed sources that they're using to regenerate harvested areas. In other words, instead of just getting seedlings that are grown from very local seed stock, some landowners, public landowners and larger scale landowners, are looking generally to the south and to the west for some of their seed stock on some of their plantings. This makes sense. It's just mixing up the genetics in order to provide more genetic diversity, and in particular, more genetics from the conditions that we're expected to see in the future, like the maps that I showed you earlier, that 9-map grid. Diversity in stand structure. So you might have a big red pine stand, and you might say, I can't do too much to diversify that. Looks like my video just went blurry. It looks like it must think I'm the background now. Anyway, you might just have to deal with me as a blurry guy. But there we are. You know, thinning that stand, creating patches of younger trees, diversifying the structure of that stand, vertical and horizontal structure can help. Again, that affects how a windstorm, wind is a really important form of disturbance around here. That'll affect how wind hits the trees. It'll affect how, you know, soil moisture based on tree density and so forth. Another form of response diversity is reproductive modes. So you might be familiar with jack pine cones, which generally, at least on some of the jack pine in Minnesota, don't open until there's a fire. So those cones will stay closed until a fire gets to about 140 degrees Fahrenheit, and then they'll open up and drop their seed right after a fire, which is a perfect time. That's when jack pine wants to regenerate because it requires full sunlight. Other species require birds to move them around. Other species might sprout from the stump. These different reproductive modes have important implications, again, for how a forest responds to various kinds of disturbance. An example of that is a storm that occurred right around the time just before I moved to Minnesota 23 years ago now, July 4th, 1999. And if you look at this, you can see a couple of things. You can see a lot of trees that were blown down. Right in the foreground here is a relatively large aspen that broke off and blew down. You can see several others. But look what didn't blow down. Couple things didn't blow down. Here's a young whippy birch. Just like I was saying, that thing probably bent way over but didn't break because it's thin enough to withstand that. Here's a little spruce, short enough to be protected by the surrounding trees and not to break off. Some white pines, larger trees in the background here, might have just been strong enough to withstand that wind. And a variety of other species. So this is a mess. I mean, make no mistake about it. But when you look at disturbances like this, if you look carefully, it's far from everything is decimated. A lot of trees are going to survive this. And you know, that's because of the diversity in ages and species and so on that we see within the stand. So what can you do on your land? Well, obviously you can, when you have opportunities, you can increase the species mix. So Blandon Paper Company is a big proponent of this. They do it on a lot of their land. They're mixing spruce and aspen on the same acreage in order to produce these what are called mixed woods stands. They have found from their own research that both species grow faster when they're mixed than they would when they're alone. And you know, this kind of thing, spruce and aspen is just one mix. There are many other ways, many other species combinations you can use. Increasing the shade tolerant component in mature stands. This kind of happens naturally. This is a similar sort of picture. This, you might look at this stand, you know, 40 years into the future, and it would look something like this. But shade tolerant species like spruces and firs in northern Minnesota, others in the south, can fill growing space and ecological niches that you know, that otherwise would not be filled, giving you some diversity. So if all this aspen gets killed in a drought or in some other for some other reason, you've got spruces or firs already on site to fill that growing space. Just another picture of a similar stand at a different stage, kind of somewhere in the middle of those last two I've shown you. So this idea of bulking seed lots is what I mentioned before. You can mix the seed sources that you're applying on your land in ways that give you not only, even within one species, you might have different genetics because you're using seed from different sources. These are all things that you can look at as you're working on your woods. So I'm going to talk a little bit about native plant community considerations. So some of you may be familiar with this really wonderful book. I need to update my my citation at the lower right because there's a new edition of the book. It's really a wonderful book about, it's called Minnesota's Natural Heritage and Ecological Perspective. And if you look At the highest level, you see basically 3 biomes across Minnesota. These can be characterized in a variety of ways based on soils, based on the predominant tree species and other things. DNR has good information about this, and you're familiar with this. It's basically on the right side of this slide, western Minnesota is predominantly prairie. That band through the middle is the eastern broadleaf forest, big woods, it's sometimes called. And on the left side here in the northeast corner of the state, it's the Laurentian mixed forest, again, what we think of as kind of the north woods, aspen, spruce, pine, fir, and so on. So again, I'm not going to go much into this, but I encourage you to dig into it if you're interested. Minnesota DNR has developed a really robust, really detailed ecological classification system that can give you a lot of information about the woods in your area. It doesn't go right down to your 40 acres or whatever, but it's not fully mapped. But you can look at the different plant communities that they've characterized, and you'll see some things that look familiar on your land, and that'll help you to understand what kinds of species might belong in there, how you might work with the natural ecological trajectory of that stand. I've already shown you this. This is another good source of information. Kind of these are categorized based on regions of the state. And so the little colored boxes that you see down at the bottom of each square give you an idea of what part of the state these species might thrive best in. And the idea with all of this is to work with what's going on naturally. So in general, I've talked about mixing genetics and so on, but in general, it's a good idea to work with what's already there, not to wipe it all out and start with something brand new. You want to favor existing species. That's one way to increase diversity. You want to look in your woods at what's doing well here and maybe what's not doing so well. And obviously, expand or try to favor the species that seem to be thriving, and maybe put less attention or really work hard to protect the species that look like they might be losing out. That's up to you. You can think about kind of how you want to manage that based on what you're seeing on the ground. So expanding existing patches. So if you've got a patch, this is a kind of oak, basswood, maple stand with this nice patch of big tooth aspen. It's all big tooth aspen in that little patch. It's a little bit hard to see, but all these young trees in here are big tooth aspen. Well, you might, if you were to take down some of these trees on the edge, that would allow that patch of big tooth aspen to expand. It seems to be doing well. That might be a way that you could, diversify that part of your woods. So I just said a minute ago, if you see what some species are losing out, well, maybe you want to not work too hard on those, but maybe you want to do the opposite. If you've got a place in your woods that stays cooler and wetter than the surrounding area, you might want to think of that as a climate refuge and really favor species from the north, kind of the boreal forest species, like some of the pines, birch, paper birch, black spruce certainly, and some others in those climate refuges or cooler, wetter sites. So I'm going to talk next about resistance, resilience, and response, or transition. So just kind of a basic framework to think about climate adaptation ideas. So the first one is called resistance. So under the resistance idea, we know things are changing, but we're trying to hold it back. We're trying to keep what we've got here. Good examples of that, if you have a black spruce in your yard and it's not doing well, and black spruce doesn't do well in warm conditions, well, you might water it. You might make sure, you might give it a little bit of extra TLC to make sure that tree has everything it needs to stay healthy. You might eradicate invasives. A lot of invasive species that are moving across our state are doing better in under warmer conditions. You might work hard to kind of resist their expansion by eradicating them. Burning on a small scale, obviously done very, very carefully. Reintroducing fire to our fire-dependent ecosystems can be a good thing. Obviously, these resistance strategies are best suited to small, accessible tracts. You can't water your 40 acres, but there are some things you can do. So resistance is trying to hold it back. Resilience is a different kind of approach. Under a resilience approach, what you're trying to do is help your forest bounce back on its own from a disturbance. So resilience is defined as the ability to bounce back or to return to a prior condition or a condition similar to the prior condition after disturbance. So that doesn't mean that you're out there doing a lot of stuff. It means that you're setting up your forest to be able to do that on its own. So strategies like thinning, which give each tree out there a little bit more growing space, make each tree a little bit more vigorous. Those things can help to increase resilience. So trees aren't just on the edge, getting squeezed out. They have plenty of energy to fight off pests naturally. Increasing species diversity, like I've already talked about, this functional response, diversifying your woods is a really effective way to increase the resilience of your forest. Maintaining vigor in a variety of ways. Thinning, both of these are good strategies for that. But some species like bark beetles that affect our red pine in particular, will, once they get into one small patch of trees, if they can overwhelm those trees, then they build up their populations. And even though they don't normally have a big impact on healthy trees, once populations get high enough, they can spread and they can kill healthy trees. So, monitoring carefully, looking for outbreaks, getting rid of those diseased trees quickly before the pest populations can really expand. That's another way you can increase the resilience or maintain the resilience of your woods. And this is really one that you would adopt pretty rarely, especially on small ownerships. But if you're looking at an area and you say, my goodness, the previous landowner planted, red pine, on this southern Minnesota area, it's all looking bad and climate projections look worse. Maybe I should think about starting over. That's what this is. This transition approach is enabling or maybe accelerating the process of helping forests transition to a better suited group of species for that site. Again, this is done, like if you look at the big public landowners, this is done very little now. Some of this is being done experimentally. You want to be cautious. In general, it's a better approach to kind of go with what's working well in your woods. But, depending on what you have on your land, this is something you could think about. And this gets into the idea of kind of assisted migration. So I've already talked a little bit about bringing in, varying your genetic stock. Assisted migration is the idea of taking trees from one area and moving them to another one. I can talk a little bit more about that if you're interested with questions and answers, but you want to be cautious about this because you don't know exactly how new species are going to respond. And just to be clear, when I talk about assisted migration, I'm definitely not talking about moving species from one continent to another. That's how we ended up with buckthorn. That's how we ended up with emerald ash borer. I'm talking about moving species from a couple 100 miles or that sort of thing. So again, we can talk about that more if you're interested later. That basically concludes the talk. I said before that I have my slides linked here. You can see the URL there at the lower kind of right side of the screen. All of the slides I presented, you'll be able to see all of that. The links should be live if you want to dig deeper into any of those topics. So it's 9:36. I had hoped to stay to 25 minutes. It looks like I was more like 30 or so. But I am available and happy to answer questions or talk about this for as long as the rest of you would like.
Thanks, Eli. Wonderful. Do we have any questions in the chat from Terry? Well, why are
Yeah, why are the bur oak seedlings planted so close to each other? So you're talking about in this picture, Terry, I assume? I'm not sure I completely understand the question. So this is a bur oak savanna restoration site. This is a little bit unusual, but it's a, yeah, okay, I see you confirmed that. They are probably, I don't know, 20 feet apart, something like that. Now, if you, I don't know how familiar you are with kind of the tall grass prairie, bur oak savanna system, but you're correct in asking that question, I think, because typically they would be more widely spaced than that in a mature bur oak savanna. But you don't know which, if all of these are going to survive. You don't know what's going to happen as systems like this get established. And it may be that they wanted to establish these trees a little bit more densely than they might have wanted them to be at the end of the rotation. You can always cut some out, change your spacing up, thin them out a little bit later on if you want. But I should note that, again, if you're familiar with savannas, you know that they're much more widely spaced than most, certainly than most forest ecosystems. This is more like what's ecologically called a woodland, which means it's not a super dense closed canopy forest. It's a more open mix where you got a lot of space between trees, and you can see between the crowns of these trees, there's plenty of room. These trees, the crowns are not touching. There's plenty of room between them. And we know that as bur oak gets bigger, it can really spread. So yeah, as they get older, there will be contact among the crowns, but that's probably what they had in mind in establishing this the way that they did. Yeah, Terry, you're absolutely right. Quarry Hill Park, Savannah Preserve. Yeah, the bur oaks really can spread out. So I can't tell you, this is a private landowner's, parcel. I can't tell you what his plans are exactly. I don't remember if that question came up. This was on a tour that I attended with the local Society of American Foresters group. But I'm guessing that you're absolutely right, that in his vision, some of these trees would die naturally or might be removed later in order to accommodate the full development of that system.
Good questions.
Yeah.
You're right. I think I've seen even some spacings of even 100 feet in some of the oak savannas that we've been researching. It's quite amazing that how their reach in time, obviously. And maybe this landowner maybe wants to do some harvesting of some of these younger ones and thinning during that time period, and then obviously allow more growth to the other ones. Any more questions, Matt? You can certainly unmute yourself if you'd like. I'm going to share my screen here, I think, on top of.
Well, I know Donald had a question. He might be typing it right now. I know I messaged with him. And Donald, if you've got that unmute button nearby, I say, you can just hit unmute and maybe ask.
All right.
Be easy.
Can you hear me?
Yeah.
Okay. Yeah, I can talk faster than type, but I've got red pine, about 60 acres of 80-year-old red pine in Sandy County, and we've been thinning it every few years and really getting some nice trees out of that. Yeah. But now I've noticed, especially after the dry summer, some of the red pine aren't doing very well. It's probably exactly what you're talking about. It's sandy soil, dries out. So I'm saying, what should I do with that? Should I accelerate the logging of it and plant other species? Or, any advice you have would be welcome.
Well, Don, first of all, I want to say hello. I saw I misread your name as Don James. I know you and I have been in touch a little bit over the years too. So it's good to see you, and yeah, it's good to touch base. I think you're doing exactly the right thing. So thinning has complicated effects ecologically, but generally it's good, because what you're doing is you're reducing the number of stems and reducing competition underground for water. So when you're in ecosystems that are predominantly water limited, and that's not true of most of Minnesota, and we have plenty of water here in most places in most years, that underground competition for water is usually not an issue. But on very dry sites like yours, just like in, I mean, if you go west of us into South Dakota, Intermountain West, whatever, it's very different. Those systems are very much water limited. And so even though there's all kinds of light, you see these wide open park-like stands, and that's because of limited water underground. And thinning can spread out those trees and increase the amount of water that's available to each tree, and thereby help those trees and the whole system, come through droughts better. So if you've got a stand, I mean, Isanti County, again, most of the time should be just fine in terms of water availability, but we have had some droughts recently, and it's quite possible, if you're on real sandy soils, that there is some water that to some degree that system at some times is water limited. So thinning is a good idea, but you want to minimize disturbance. I mean, none of us can see the future. You don't know when the next drought is going to be, or how severe it's going to be, or any of that. And you do, to the extent that you can control it, you want to really limit the amount of disturbance, in this case from timber harvesting, that you impose on a stand while it's already stressed out. So it could be, and again, I would need to walk your land and talk about the timing, or you'd need to talk to your forester. It could be that there are some impacts, some negative impacts from the thinning treatments combined with some of the recent droughts that we've had. So that's possible. That doesn't mean the thinning was a bad idea. It means that maybe there was some bad luck. So how does that happen? Well, maybe logging equipment compressed the soil and damaged some of the roots of your residual trees. Maybe, and this would be easy to observe, maybe some of those trees got bumped and some of their bark scuffed off, which would limit their ability to move water up and nutrients down from the photosynthetic parts. Maybe something else is going on. What I would really suggest is look carefully for evidence of bark beetle infestation. You'll see some. I mean, if you look carefully at any red pine, you'll see little, teeny little, like 1/16 of an inch diameter holes. Seeing some of those is not a problem. Don't panic if you see some. But if you see trees dying and you get a forester, maybe from the DNR or wherever out there, and if you do have a bark beetle outbreak, then you may want to take appropriate action, which might mean harvesting the most heavily infested parts of that stand, or doing other things based on the forester's advice. I hope that answers your question, Don. It was a little bit of a long answer, but does that help?
Yes, thank you. And I think it was 1988, we had a bad drought.
Yeah.
And I did lose maybe less than 1% of the trees to pine bark beetles. Then the rain came and everything recovered again.
Yeah, they should.
A few areas don't have live trees anymore.
Yeah. Well, hopefully, if that's what happened this time, that you can get it quickly and keep those trees healthy. Terry, I see a question about garlic mustard and how it alters the soil and affects the interaction between fungi, mycelium with trees. I don't know much about that. I can talk to you a little bit about garlic mustard. Garlic mustard can form a super dense carpet of understory vegetation that can really limit, it can change the chemistry of the soil. It can really limit the ability for trees to grow, to regenerate mainly. How it affects interactions between fungi and trees, I don't know. I don't know. I know it's a tough invasive, and it sounds like you're down near Quarry Hill. Garlic mustard well, and you're part of the state, unfortunately. But I'm not too. I can't say much about specifically fungal interactions with garlic mustard?
Well, I just try to pick anybody's brain who's talking about woods and invasive species. I have done a lot of reading. I've seen a piece of research that was done by Harvard Forest School years ago.
Yeah.
And it does impact the ability for the trees and the fungi to interchange nutrients. And so that the trees aren't getting what they need because that connection's broken.
Yeah, that makes sense. I mean, they can change those systems so dramatically. It's not at all surprising to me that would be the case. And there's been some research recently that's been really fascinating about the important role of fungal components of soil in the ecosystem and how fungi help trees to get the nutrients they need to maintain an appropriate water balance and so on. And any disruption like that, like the invasion of garlic mustard or others, any major, change in the species on the site, it's not surprising that would lead to changes to the fungi, which would then affect the trees. Earthworms are another one. And Terry, I'm sure you've seen this in your part of the state too. Earthworms can have a dramatic effect on soil density, soil composition, organic matter in the soil that's available to trees. They can entirely consume the duff layer, which is really essential for a number of trees to regenerate. And they can change ecosystems pretty dramatically. I guess the driftless is the one part of the state that earthworms are native because it was not glaciated in the most recent glaciation. But in the rest of the state, earthworms are not native. Our forests evolved under conditions where there were not earthworms. And again, not to go too deep into that, but that can lead to similar changes to what you're discussing.
Eli, just one more comment for Terry. I have heard some allelopathic type qualities that garlic mustard does give off in the soil, almost like black walnuts.
Yeah.
That prevents other species from growing and so forth. So yeah, I think more research is being done on that. And yeah, it's quite interesting. So another negative for garlic mustard.
The one positive, and then I'd love to hear from Jennifer, the one positive on garlic mustard is that it's so darn good. I often go for walks in the summer and get home with a handful of garlic mustard that I then eat for lunch. Literally, seriously, it is very tasty. Jennifer, what's on your mind?
Well, I've been pondering cumulative stresses to trees, and I have a short list of what I think are highlights, and I want to see if you can think of anything that I've missed, partly because I don't get out a lot in the summer, so it's easy for me to forget things. So 2018 and 2019, both we had a winter where there were a lot of the state didn't have good snow cover. And so the soil froze really deep, which can stress the shallow rooted trees. And then we had a lot of snow, but a lot of it came in March and April, which doesn't really help the way the world usually works that much. And then in 2019, we had the big polar vortex where even in the metro area, it was -29. And we only had 4 inches of snow on the ground in St. Paul when that happened. So I think those 2 years were really rough on the trees. Then also in 2019, we had the record rains, and there were a lot of foliage diseases. And I had a lot of calls from people where the story would go, my bur oak is at the edge of a lake and it died. And those stories, I think every sample I got tested negative for oak wilt. So it really made me wonder about the water table that year and if some of those trees just suffocated in the rain. 2020, I'm struggling to remember, which is why I'm talking to you now, because I don't know, it's just maybe the pandemic took all my brain space. And then we had the drought last year, but I feel like I've just named off a lot of really big stresses to trees in a fairly short amount of time. And what I see in the plant disease clinic is we get more and more tree samples. I feel like I hardly do anything else besides trees anymore.
Well, I suppose that's good. Jennifer, I was just piecing together. I remember talking to you both on our bikes on the way into campus and other things. And I was pretty sure that was you from the plant disease clinic, but I wasn't certain. So it's good to hear from you, and I'm glad you're here. That is so really interesting. I don't remember what happened in 2021 either. It's such a weird time that we're in. But you know, some of the things that you mentioned, I think, are bigger issues than others. You know, we see these big, you know, you mentioned the polar vortex and it was -29 in the Twin Cities. That's really not that abnormal. It's abnormal recently. I mean, it's not as common, and maybe in the last few years. I talked at the beginning about warmer temperatures, particularly in winter. But I would think that our trees are pretty well adapted to that. Now, you did point out shallow snow, and you said that right in concert with that. So what really can happen, it won't be that the cold kills trees, but as you pointed out, if the roots and the soil are frozen, then we get to spring and they remain frozen for a long time, or you just get, you know, dry winds blowing through. There can be desiccation related to that cold that does lead to stress. And we sometimes see conifers turning red late in the winter, early in the spring, when soils remain frozen, but that those trees are trying, they need, you know, they're losing some water to evaporation and they're unable to take up additional water. So those things, so you've identified a number of sources of stress, and you know, those again will have sort of different effects on different species. In general, though, I think it's safe to say that in the woods, which is different from maybe the places right around our St. Paul campus and so on, which are mostly planted trees, but in the woods, those issues are less serious than some of the others. Yeah, interesting what you're saying about, and I would love to chat with you a little bit more about trends and what you're seeing at the plant disease clinic. I know bur oak blight is, you know, something that people ask about a lot, and oak wilt, of course, is expanding its range within the state. We see it moving kind of north from, you know, beyond its known range. And all of those things, I mean, certainly those, you know, the cold, the droughts that we've seen periodically can all predispose trees to damage associated with insects or fungal pathogens that wouldn't really normally be a big deal. But when trees are weakened from other things, they can have greater effects.
Well, if you think of anything to add to my list, feel free to send me an email. I did think of one more thing. Well, while you were talking, last spring, we had a lot of fluctuations in temperature. We had a really early record high temperature, and then it was back into the 20s and 30s again. So fluctuations were, I think, a pretty strong theme of 2021 to go along with a memorable drought.
Yep. The other thing about the things that you're mentioning, and they're all real for sure, but they're also pretty localized and variable from place to place. Most of my work is in northern Minnesota, and you know, those things had different effects and different patterns, different intensities in different parts of the state. So I'm you probably see the worst of, and have as much cause for worry as any of us here, because all of those disease reports go directly to you at the plant disease clinic, and you see those fluctuations, and it would be interesting to see kind of how your observations are changing. But yeah, you're right, that happens from time to time. We have had, you know, bud break followed by frost, you know, lots of years, and I think you're right that happened recently, at least in some parts of the state. So I don't have anything to add to your list, but good question.
Well, I'll keep working on my list.
Yeah,
great. Jennifer, thanks for joining us today. That's great to have you as a resource.
Thanks.
I just put something in the chat, a link that is from the Regional Sustainable Development Partnerships. They're actually planting seed of trees from southern Minnesota in northern Minnesota, and in pots, and propagating trees and planting them. That's a project you look there. And actually, we have a question from Mary. I don't know, Matt, if we addressed this, or Eli addressed this. Are the cottonwood trees from southwestern Minnesota appropriate for transition planting in the Brainerd Lakes area of the state? And I don't think on that research that's being done on transferring some of the seeds from the south to the north, I don't think cottonwood is one of those tree species that that they're working with. But anyway, you can expand on it. Anyway.
Yeah, it probably wouldn't be my first choice. Cottonwoods can be wonderful. Hey, if that's your favorite tree, that's awesome. But it probably wouldn't be the first one that I would move up. Is it, it doesn't have a lot of pests and pathogens that I'm aware of. I mean, you could sure give it a try. I don't know. I wouldn't expect it to be a big problem. It's just it's not everyone's favorite because of the cottony seeds and some other things. But it could, and I think that in the forestry world, I mean, I spend a lot of my time working with county land departments, with the Department of Natural Resources, with organizations and companies that are managing thousands and thousands of acres. And we often, they're reluctant for very good reason, and I think they should be reluctant, to plant a new species across hundreds or thousands of acres until they have a pretty high level of confidence that it's going to thrive in that area. Homeowners and landowners like you have a little bit more flexibility to just try things. And again, we are seeing those larger agencies and companies trying things on a small scale and experimenting with some of those things just to see, so that they can learn what's going to thrive. And so you might give it a try, Mary. I wouldn't encourage you to invest thousands of dollars in cottonwood in the Brainerd Lakes, but there's cottonwood around there. Moving species, moving cottonwood with southern Minnesota genetics up to Brainerd. I don't know how it would do. But again, it's like, that's a relatively innocuous thing. That's not like moving, a new shrub species from one continent to another, leading to a massive, invasion of buckthorn. So maybe give it a try if that's something you want to do.
Eli, could you stop sharing? And I've got a few more slides to show for people before people leave. If that's
Yeah,
right.
I think so, Gary. I had to hide my, there we go. All right, I stopped.
Okay.
Thanks, everybody.
Well, do you see my screen there, Matt?
Yeah.
Full screen? Okay. Excellent job, Eli. Just wanted to reinforce the fact that obviously Eli can be reached from his email, Sagor at umn.edu. And then obviously Matt Russell and myself can be reached for questions if you'd like to. Our Fridays with a Forester are recorded and going to be at the Z link, the z.umn.edu/Fridays. And I'm going to see if I can advance the slide here. So some of our upcoming webinars on Fridays with a Forester, the next time will be April 15th, which will have Charlie Blinn and Jeff Jackson talking about timber sales and wood products. Then we'll have woodland grazing, and then family earth care. And then actually, I think Jennifer Teagarden is on the line here. We're thinking about maybe hosting a DNR Forester or some of the DNR Forestry staff on May 27th. And Jennifer, you can get back to me this weekend or next week, and we'll try and line something up there. And then let's see, as you leave today, you'll be asked to complete evaluation, and we'd like to have you evaluate our programs. And if you have some comments on today's program or future programs that we want to host with Fridays with the Forester, we'd love to hear from you on that. And let's see, oops. Then here's our connections mainly with My Minnesota Woods. If you're not connected to My Minnesota Woods, it's a monthly newsletter, and we have a lot of posts there. You can access that Z link, z.umn.edu, My Minnesota Woods. And yeah, any final questions, Matt or Eli, comments?
I don't think so. Thanks for having me. This was fun. I hope it was an informative session.
We're right at 10 o'clock. Thanks everyone for joining us today, and we'll see you next time on Fridays with a Forester. Thank you.